Okay, on this one I decided that I'm tired of making graphs in this case. So what I wanted to do in this one is talk about how you could even use a table, as they gave you an option to do in this problem to solve a system of equations. A lot of books kind of gloss over that you can use a table to solve a system of equations in some circumstances. Basically, if you could use a graph to solve it, you can probably use a table most of the time. It's just less visual, but you do see the numbers match up, so that's nice. Basically what I've done is I've separated and made two input-output charts, XY charts, and T charts if you want to call them that. And I want to see, are there any pairs that are going to match up that would be in the first table and in the second table? So if I wanted to look at those, I could say, well, let's just make x equal 0. I'm going to let it equal 0. If you did that, then x would be 0, so y would have to equal 11 in that case. Well, that's good. That helps a little bit. If I went to the other one and made x equals 0, I would have 0 minus y equals 1. Well, in order to make that true, y would have to be negative 1. So those don't match, and since they don't match, I would say those are like 12 apart from each other, the y values, even though the x values match. So that's not our solution. We could go and put a 1 in. If I have 5 times 1 plus y, then y would have to equal 6 to make this match up. Well, in this case, if x is 1, 1 minus 0 equals y. Again, that's not a match, but what I do notice is this. When you compare the y values for 0, 11, and 0, negative 1, those were 12 apart. But 1, 6, and 1, 0, those are only 6 apart. So they're getting closer, which is going to lead me to where I'm going next. 2. If I would have made them further, like if these would have been getting further apart, 6 and 0, they're closer, but if they would have gotten further apart than 12, I would have said, I don't even want to go in this direction. They're getting further away from each other. I would go in towards a negative 1 and stuff like that. But if x equals 2, 5 times 2 is 10, then y would have to be 1 to make that add up to 11. So filling out a chart, I'm working on everything there. If I put a 2 in for x here, 2 minus something gives me 1, and that something has to be 1. And I was able to solve this with a chart really quickly because I see when the input is 2 for the first one and for the second one, I get an output of 1. And that's why I know that that has to be the only solution to this system of equations.